Sergey is talking about Android, and I thought, okay, I'm playing around at Hypres. I'm working at Hypres Lab, so we are a small group inside of Hypres Lab, inside of SAP Hypres and inside of SAP. I think you know SAP. And there we are working in Hypres Labs. We are playing around with e-commerce platform. That's one part of SAP Hypres, and we are trying to use new technologies to connect this with the e-commerce platform and look what's possible for the future. And therefore I'm playing around at the moment with the new iOS 11, which is in beta stadium, and Apple announced this at the WWDC this year. And one of the part was CoreML and also the AR kit for augmented reality. So that's one part I'm playing around with, and I thought, okay, Sergey is doing something with Android, I'm doing something with iOS. Okay, what's CoreML? So as we heard, we train our data. So this takes long time. And so you don't want to do this on a mobile phone, like on the Android. You don't want to train all your data with 1,000 classifications or something on a mobile phone. Therefore, you have big machines with GPUs or such other things. And the idea of CoreML is you take this trained data and format this in a CoreML file, and then you can use it in your app. So one point Apple was talking about, so all your data could stay on your mobile phone and don't have to go to some big brother you normally send your data. And also the other thing is the performance stuff, so you don't need an internet connection, which is maybe laggy or not. You just run the stuff on your machine, and therefore you don't need an internet connection, and yeah, it runs on your machine and could be more faster. So yeah, what's the ML model? So this is one of the files. When you go on the Android, not Android, sorry, on the developer page of Apple, they already have some models. So in here you can see, we thought today often there Intercept version 3, for example. You can click on get some information, and there's also some paper. It's what's it, the 1512-00567. So they describe why there are why the Interception version 3 is better than the previous version. I think the Google Nets, they're based on this data. So that's one thing. The other thing is also that you can train your model by yourself and then convert this into an CoreML model. So at the moment, there's a CoreML tool, which is also a Python tool, and this is supported tool. So you can see Caceres, which uses TensorFlow in the backend, and also for different types of model types like tree assembly, you should use scikit-learn and everything. So you train your model, and out of this, you include this in your app. So I thought, okay, a demo is better than lots of slides. So I just looked at the internet and looked for a simple Keras model. So this is Keras, as we saw already today. And this model is doing an XOR calculation. So I think maybe you know what the XOR calculation is. At top you can see it. So if you have a 0, XOR 0 will end up in a 0. If there's somewhere a different value, you get a 1, and for example 1, 1 will also be a 0. I don't get into this model. I think, maybe you understand it, otherwise you will not understand it tonight. At the end, or someone interested into this, I'm not sure if I can explain it, that's the problem. The more important part is at the end. So you import here the CoreML tools and just write out the model you've trained. So with the fit or compilation of it. You run through it, get your model, and this one is, where is it? Model. Here's it as input. And then you could also define some names and everything for the CoreML, and then you save it as X or ML model. So I have also a short demo for this. Which one was it? This one, yeah. So here I just run it. As you can see, it uses TensorFlow as backend. Run 1000 epochs, which is not so long. Now it saved the model and we are done. And here I have already prepared, is it this example? Yeah, simple example. So this is the model. As you can see, I also used the timestamp as a description. So it was just created at the moment. Or maybe I did some good prep, yeah. I thought it will be at this time, so no, it wasn't. It was created now. As you can see, some description, and we have input 1 and output 1. As input 1, we need 2 double values for the 0, 0 or 0, 1, and as output, a 0 or a 1, or something like this. And here we have the code for this. So this is everything you have to do. You need your import your model. Oh yeah, I forgot to say. When you track this file in, code Xcode, create some file out of this. So and therefore you can just import it into your file in your app. In this case, you take here the XOR model. Then we need some input data with some fancy multi-array stuff. In this case, I'm using 1, 1, which should, yeah, at the end there should something be around with 0, as you can see already down here. So I changed this one to 0 before I run it. Then we use this as an input 1. Then we do our prediction on this, get a prediction, and out of the result we have output 1, and therefore we use the first value. And we just write out here the stuff. So now I run this. I have to stop it because it's running in the background, some simulator. And it's building a model, come up with a simulator. Oh, cool. It's already not running. Okay. Maybe, yeah. Okay, cool. Plan B. I use a real device. It's also at Android. No, I don't need Android at the moment. Okay. Let's try it again. Building, and now should start up on the building successful. Cool. Running. Okay. There's nothing on the display. But here we can see the result is nearly 1, yeah. So that's also one problem with machine learning. It's nothing, it's totally clear that it's 1 or 0, it's something in between, mostly. Or often, or yeah. So yeah, that's for example. I could also change this to 0, 0. Now when I can compile it easily. I stop it again. So on the device itself, it's just a white screen. So there's nothing, no output at the moment, because I only lock out this one. So 0, 0 would be also be nearly 0. Okay. So CoreML is running on also the Metal performance shade. So they're using the Metal backend or graphic stuff. And on this, you can add the vision stuff for images or for natural language processing, or also GameKit is possible to add on this and then use your app. The demo I used before just used the CoreML directly. So what I'm playing around with at the moment is something like using CoreML and the AR kit, and you scan some item, for example, a bottle or something, and then it writes in the air, depending on the surface. So for the augmented reality stuff, it takes the picture, recognizes the item of it, and then draws it in the picture itself. And when you walk around, you can see where it is written, and yeah, as you can see. And for this, I'm using the Intercept V3. I don't know, it's always old, because it always detects an iPhone as an iPod, since it looks the same, yeah, but I think it's all data always. And yeah, therefore I'm using also the vision model. So when you take an image, it doesn't, so I can show it here. I have a demo for this, but I don't compile it, don't worry. So in this case, I'm using the Interception V3 model. And as you can see, it uses an image as input and needs a special size, 299 by 299. And then you get some prediction with a class label for this, and also with some value. What's funny? Ugly shoes, yeah. I'm scanning ugly shoes. We have totally ugly shoes upstairs, and yes, right, to figure out which one is more ugly. That's the idea behind it, but yeah. I will change this demo, because you couldn't use this ugly shoe, so it's more like a bottle, maybe not. A coffee cup. I have a coffee cup with me, so this will be recognized and something like this, so yeah. And with the vision, oh yeah, what I want to say, so you get an image with RGB, or maybe the other way around with BGR, and when you don't use the vision model, you have to transfer your image in the right size and everything. With the vision thing, it recognizes the image itself, where it's lying in your picture, and also shrinks or yeah, also reduces color or something for your model, and then you get a prediction out of this. So yeah, in this case, this was an example for this, and it's running also on the iPad. So if someone wants to see it later on, and I have the coffee cup with me. I think that's it, yeah.
I think it was like one of the best demos, right? He brought device, coffee cup, and like everything with him. So there is no way it's gonna fail. So what kind of questions do we have in the audience? Yes.
So what sort of performance can you get with this? Is it some sort of like CoreML could be used with live imagery from the camera of the iPad and yield 30 frames per second, or is it more like 1 frame per second? I don't know.
It's used also for videos to recognize. So on the WWDC, they used it for with a video camera. I didn't run this on. I didn't try it by myself, but you can run around and see directly what's in front of your camera. And they use the joke that's not a hot dog for a banana. So if you know this joke.
I mean, essentially, they're not going to run it for every frame, right? I think they still like do like every whatever 20s, 10s or something. But for you as a user, I think it's easy to track, you know, what objects are staying where, and you can just like optimize for those objects that you're recognizing. So some cheating in between. Next question, or? No, nobody wanted questions. So just like, oh yes, you're always saving the thing. We need to have you like as VIP guest.
Yeah. So, as I understand, CoreML is another machine learning framework, and so we have TensorFlow, Theano, MXNet, Caffe. So why
No,
another framework again?
No, wrong. You use some of these frameworks, and CoreML is just using the trained model.
Okay.
You get the trained model out of TensorFlow, for example, or Keras, for example, were used here. And this trained model is transferred to a CoreML model with a ML model. So it's nearly the same you get out of TensorFlow.
It means you make it accessible for Apple devices.
Yes, right.
Okay,
So
got it.
what they are doing is just to generate a little bit code around it, so you can use it for the constructor and input and output value. So that's the main idea behind it.
Just like follow up to this one. So if you heard Keras today, right, it's kind of syntactic sugar, kind of like nice language to write it, right? In the background, they might be like a different backends. Like a TensorFlow is like one backend, right? PyTorch was like original backend. CNTK is also one of them, right? In order to execute this one properly on hardware of Mac, right, they use like a CoreML that might be already like, you know, middleman in a way between like a hardware of them and the model itself. And after you can export the model from Keras or I don't know, like some other things that they were running there.
Caffe was also.
Caffe as well, yeah, like one for Facebook, and just execute it directly on device. So it's more like something to be like, as a backend in a way, so it's not executable. Yes.
Hi, stupid question. Do you have some examples of world life applications using CoreML? I mean, in the frame of HANA or SAP projects or so on?
So live applications with CoreML. CoreML is in beta at the moment, so there are just some demos with image recognition, or they use something for house price prediction as a demo. So there's nothing at the moment available where no for real. For SAP, I'm talking only for Hybris Labs, so I'm not talking about SAP Hybris itself, and none for SAP for this. So the machine learning stuff could also be running on a server side on a HANA machine in Waldorf, for example. I have no idea for some future stuff, but it also could run on a mobile device. So. But I don't know if there are any plans, so.
Just some kind of imagination. I mean, like I've seen your lab just like close by, right? And you had some real objects in there, right? So what you can do theoretically is using like a loss layer and pre-train to recognize your own items, right? So it can understand this like a wine, your specific wine, and blah. And basically you can map it to actual, you know, your categories, right? Something similar what we do with fashion, right? We have different, you know, shoes, shirts, blah, and we like can train it to understand what those objects are. So theoretically you can use a mobile phone like in, I don't know, your supermarket or whatever you use, like SAP HANA and Hybris, and basically being able to understand this, like this on a chair, right? The price is blah or something in the direction. But it's just my crazy imagination, so nothing to do with real life.
I mean, it depends on what data you have. So if you train your model, your shop, for example, all the items, then you can put it on the device, for example. If you run around all over the world and want to figure out what item is this, so maybe you need some server side for this, where the model is bigger or something, so that's different.
Okay. Do you know if models can be switched at runtime? Or even better, downloaded at runtime and switched? So, like, you think so, or? You know?
What I've used, I used two models. You could throw two models inside of this. I'm not sure if you could download something externally.
That's probably possible with Android, that's for sure, but
it should be possible also, but I didn't figure it out, so okay. Maybe it's possible.
Okay.
So you only put your small app on the App Store, and takes a while to download the models.
No, what I mean is, I don't want to the App Store thing, the 2 or the 3 days or something. I want it to download,
Yep.
like the Android can do. So I can somehow improve my model and collect even label data from the app and push it back into my learning system and download the improved model.
Okay, I
directly
didn't try
from
this.
the app
I didn't try
into the
this.
app.
If it's possible to download the model itself, maybe I have no experience with this.
Okay, thank you.
Right. Now you so this model is just pure data. This falls out of Keras, for example, and then Xcode is generating this code here. But this is doesn't have to be really with the model data. There's no connection with the trained data itself. It's with the structure. So if I would take the same structure and would use the XOR example, which makes no sense because it's an image in this case, but would use also some image recognition for myself, like the ugly shoes, when I would use also the 299 by 299 RGB, then I just can throw out the model and use this one when I name it the same. But I don't know if it's possible to download the data during runtime, so that's what I didn't figure out.
So like as you said, on Android side, it's definitely possible to download and load it. There is also like a paper what Google call like Federative Learning. So basically like in a way federation. So you have like pre-trained on generic user data, and after, let's say, after completion on a keyboard, right, might be like super specific for you and somebody else, right? And you cannot really put this one on cloud because you're also disclosing how people and is it dead? No, what they're writing. So they kind of have pre-trained generic thing, let's say for region, right? And after you can pre-train for a specific user like afterwards. So it's more like flexible basically, and you can get the best of the worlds, like predefined beforehand and after like more advanced for every user. So there's like different things. Yes. Anybody else? The last one? No, okay. I'm kidding. Yeah, as I said, if you have anything, yes, you will way too shy for that, man.
Last one, super silly question. Why did you choose 299 pixels and not 302?
I didn't choose this. No. I think it's has something to do with the model itself. When you train it with a convolutional layer, maybe they use a 3x3 layer for this, which moves around with some space around it.
I think it's just pre-trained like that. So Apple decided that 299 for you is perfect.
No,
that's why we have.
It's not the Apple thing. It's the interception V3 use this.
I mean, usually you can still like normalize it beforehand and like feed into
you can
your
read
network.
the paper.
So
if someone is interested, I can start now.
The only problem, like basically, is the bigger you have like image fitting inside, the like more resources you need to like to compute that. So usually they're like downscaling those images and maybe reducing some information that you don't care about, and from there you're getting it. Did you want to say something?
So this is what they.
It has a predefined input size that's required. Most other models, like ResNet and some of them, have a variation, like they suggest 256, but then they give you a range of what's possible, usually a variation of 30 pixels width per side. But as Sergey already said, usually you do that in order to reduce the computing power that you need. So basically you limit it. You say any image you get, you have to resize it, shrink it down to 299, 224. It depends on the network architecture. And then they keep calculating from that.
See, that's community, perfect. Yeah, I think we like fine with microphones for now, so we can still like continue our discussion. As I said, like if you have something cool or like cool things to share, just like let me know and we can have like a lightning talk. Organizational stuff, like if you have some bottles of things that you drank before, please bring it like 2 boxes. It's going to be easier for me to clean up all the mess after us. Yeah, thank you very much and see you on 16th of August, I believe. Thank you. And you can still see the demo of Lars with cups and all kind of cool things.